This is a communication question, C9. In a right triangle ABC, tan A is greater than tan B. What can you conclude about the side opposite to angle A and C respectively? Explain. So we are taking time here to understand the basic trigonometric ratios so that we can easily move through this chapter on trigonometry. I've seen students struggling with this chapter, and therefore I'm taking my time to just understand what these new terms sine, cosine and tan are and how should we see them in a right triangle. So this is almost the end of our communication section, and let's try to analyze this situation. Now what we will do is we will just construct a right triangle. So that is my rough sketch, and this triangle has this right angle. Now the question here is, there's a triangle ABC where tan of A is greater than tan of B. Now what is tan? Tan is opposite over adjacent, correct? That is our angle. That's the trigonometric basic ratio about tangent of A, right? Now, so what we will assume is, normally when we say angles and sides, then this is how they're related. If I write A here, then this becomes the angle A, and the side opposite to A is named as A, right? Do you understand? And this becomes small a. So that is a nomenclature, right? So if I write B here, then the side opposite to B will be named as B. So that we say, well, the length of the side opposite to A is A, and the length of the side opposite to B is B. So that is the way we label our triangles, right? A, B, and this side becomes C. So that's how we have our triangle. So when we say tan A, we mean tan of this angle. So this is the angle being referred to here, and when we say tan B, then we are referring to that angle, correct? So those two are two different angles in this triangle. They have to be different, and if they are different, then these two sides are also different. And of course, if the sides are different, one of them will be shorter, the other one will be longer. And the longest side in a right triangle is always the hypotenuse, which is AB, undoubtedly. So we are only talking about the other two sides, the legs of our right triangle, correct? So that is how it is. The question doesn't really shows you exactly what the triangle is and which sides they are trying to talk about, but this is what you could visualize and understand, okay? So we will take that as our scenario and then continue with this problem. Now it says, what can you conclude about the sides opposite to angle A and C respectively? That means our small a is the side opposite to A and B is opposite to B. So what means is small a greater than B or B is greater than A, or you can't really conclude anything, right? So that is what the real question is. So what we will do is we'll write what is tan A in this right triangle. Tan is opposite over adjacent. So opposite to A is small a, so we'll write tan A is A divided by B, which is adjacent side. Adjacent side is always a side which is included between the angle we are talking about and 90 degrees. So for tan A, adjacent side is B. Now how about tan B? Now we say tan A is greater than tan B, therefore A over B should be equal to the tan B ratio. Ratio tan B is opposite B and adjacent is A. So we write B over A. So that's what we get, correct? So we know A over B is greater than B over A. Now we can multiply both sides by AB, right? The sides are positive, always positive. Since the sides are positive, we can multiply both sides by AB, right? AB on this side and AB on that side. If we do, then we get what? We get A square is greater than B square. Well, that's a good relation. Now we know how A and B are related. And if the squares are bigger, then the number should be bigger, correct? So this implies that A is greater than B, right? So that's the reason. You have to write your reasons here, correct? If squares are bigger, then the number should be bigger, correct? And therefore, we can conclude that side A is bigger than B. So this means this side, this leg is longer if this angle is bigger, right? So we conclude that always in a triangle, the side opposite to the bigger angle will be longer side. Okay, so that is what is a very important conclusion which we get from here, correct? So side opposite to the bigger angle, right? Because a side opposite to bigger angle, right, is always longer. So that is a very, very important thing which we learn from here. And we can also conclude from here, well, in this triangle, 90 degrees is the biggest angle, and therefore that side, the hypotenuse, will be the longest. It makes sense, right? So that is what we conclude from this particular problem, right? So the idea of having these communication questions was, one, to understand and get used to or get friendly with our trig ratios, and then appreciate them and see how they relate. So this also gives you another learning, and that is, in a triangle, if we have three angles, let's say 30, 60, 90, then the side opposite to 30 will be the smallest, right? And the side opposite to 90 will be the longest, correct? That is how we should see our triangles. Okay. Now we will get into some more problems relating to trigonometric ratios. I hope you enjoyed this journey of my set of communication questions to understand trigonometric ratios. Please share with your comments and share the knowledge with your friends. Thank you.